Hey everyone, welcome back to another CIE A Levels Maths past paper video. Today we're going to talk about paper 5.1 from the October-November 2024 series. So let's jump into the paper. Question number 1. Nicola throws an ordinary fair six-sided dice. The random variable x is the number of throws that she takes to obtain a 6. Find x less than equal to 8. Now this random variable, this is sort of Bernoulli variable, because at every trial there's a possibility that you will get a 6 or not a 6. So how we can actually visualize this is that, for example, at the first throw you get a 6 or not 6. If you don't get a 6, you try again. 6, not 6. Then again 6, not 6. The probability of getting not 6 is 5/6, 5/6, 5/6, always, because they are independent. The trials are independent of each other. Find less than equal to 8. That means we can either get 6 at the first try, at the second try, at the third try, at the fourth try, all the way up till 7th try. Okay, so that's what we need. Less than 8 means less than equal to 7. So basically it's the sum of, actually we can write it like probability of x equals to x from x equals to 1 up till 7. So now we need to figure out a way to write this. So for the first one, as you can see, this is just simply 1/6. For x is equal to 1, you will have 1/6. Then 5/6, 1/6. Then the power on 5/6 will keep on growing, right? This is the x is equal to 3. Then we have 4 more times 5/6 cubed 1/6. This is the fourth try. Then you have 5/6 raised to power 4 1/6 plus 5/6 raised to power 5 1/6, 5/6 raised to power 6 1/6. So this is the 7th. Easier way to just write this entire thing is using the sigma notation. This is your 1/6. One time 1/6 will always come. But 5/6 on the other hand, 5/6 on the other hand is coming 7 minus x basically. So x is starting from 1 and it goes up until 7. So let's type it into the calculator. So sigma notation from 7 1, you have 1 divided by 6, then 5 divided by 6 raised to power 7 minus x. So you get 0.721, 3 significant figures. Right, okay. Find the probability that Nicola obtains a 6 for the second time on her 8th throw. Right, okay. So that means 8th throw is definitely a 6, but which throw before that, from 1 to 7th, was the first one? That's a mystery. So 1, 2, 3, 4, 5, 6, 7, 8. So the 8th one is definitely 1/6. But the other 1/6, that means the 6th phase, it comes whether over here, over here, over here, over here, over here. It is a mystery. But the rest would be failures. So it could be the first try, it could be the second, it could be the third. So that means it's basically 1/6 times by 5/6 raised to power 6, 7 identical times, and then times by another 1/6 for the 8th throw. So in short, you have 1 divided by 36 for 1 over 6 squared, divided by 5 divided by 6, sorry, times by 5 divided by 6 raised to power 6, times by 7, you get 0.0651. This is question number 1. Let's move on to question number 2. Question number 2. The random variable x takes the values -2, -1, 0, 2, 3. So notice over here, no 1 over here. It's directly from 0 to 2. It is given that p x equals to x is equal to k x squared plus 2, where k is a positive constant. Draw up the probability distribution table for x, giving the probabilities as numerical fractions. Okay, so we'll draw the table later, but first let's make the this way. You have first x is equal to -2. So when it is -2, you see -2 whole squared would be 4. 4 plus 2, 6k. Then you have -1. 1 plus 2, 3k. 0. 0 plus 2, 2k. Then 2. 2 squared. 4. 4 plus 2, 6k. And then 3. You have 9 plus 2, 11k. Okay, now you can we can draw a table on top of it. Okay, however, we actually needed to find out k also, so we would actually need to redo that. So all of these, 6k plus 3k plus 2k plus 6k plus 11k, they are equal to 1, because we know that sum of all probabilities will equal to 1. So 6 plus 3, 9, 9 plus 2, 11, 11 plus 6, 17, 17 plus 11 is 28. So k is equal to 28. So k, no, 1 over 28, sorry. 28k is equal to 1, so just to make sure, 6 plus 3 plus 2 plus 6 plus 11, 28, yes. So k is 1 over 28. Now we rewrite this table again. For -2, it's -6 over 28. -1, 3 over 28. 0, 2 over 28. 2, 6 over 28. And 3, 11 over 28. Now you can that over here. Okay. Right. This is our probability distribution table. Right. Okay. Find the value of variance of x. Okay. So this is like the discrete random variable. So variance of x would be e of x squared minus the square of expectation of x. So we need to figure out both of these things. So e of x would be okay, you have -2 times by 6 over 28 plus -1 times by 3 over 28 plus 0 times by 2 over 28. Then you have 2 times by 6 over 28 plus 3 times by 11 over 28. So minus 2 times by 6 over 28, minus 1 times by 3 over 28, 0, 2 times by 6 over 28, and 3 times by 11 over 28. Okay, so minus 2 times by 6 divided by 28, minus 3 divided by 28, plus 12 divided by 28, plus 33 divided by 28. So the expectation is 1.071429. This is not the final value of variance x, so we need to retain a little bit of accuracy. You could have done additionally, just simply added them all up. So let's see whether so this is minus 12, minus 3, plus 0, plus 12, plus 33. So minus 12 and 12 would be cancelled. This would be 30 over 28, which would be just 15 over 14. I think this would be the better thing to do because, yeah, right. This way we can keep some accuracy also. Right, now we need e of x squared. So, minus 2 whole squared, so all of these that we wrote, we just need to square them. So that is 4 times by 6 over 28, plus 1 times by 3 over 28, plus 0 times by 2 over 28, plus 4 times by 6 over 28, plus 9 times by 11 over 28. So we will do the same thing. We would just like 28, 24 plus 3 plus 0 plus 24 plus 99. So 24 plus 3 plus 24 plus 99, you get 150 over 28. So let's simplify this. I go with fraction. Oh, sorry, no. Sorry. Right, 75 over 14. Okay, so now we need the variance. Okay. We already wrote down the formula. Minus the square of 15 over 14. So 75 divided by 14 minus the square of 15 divided by 14, you get 825 over 196, or 4.21. Right, so this is question number 2. Let's move on to question number 3. Question number 3. The time taken in minutes to walk to school was recorded for 200 pupils at a certain school. These times are summarized in the following table. Draw a cumulative frequency graph to illustrate the data. Right, okay. That means we need to set a appropriate scaling also. So time taken is going from 0 to 70. So let's see, 1, 2, 3, 4, 5, 6, 7 actually. So this is 10, 20, 30, 40, 50, 60, and 70. Next up, we need the cumulative frequency that is going up till 200. So okay, let's see how many boxes we have. We have 1, 2, 3, 4, 5, and 6. Okay, so let's divide 200 by 6. And 100 divided by 3. No. That's a little bit weird. How about 5? 40. So if we do 40, 1, 2, 3, 4, 5. Okay. 40, 80, 120, 160, and 200. Right, okay. First is 18, so and then we also need to know how much we are distributing. So each unit is 4. Right, okay. So 18, first is 15 and 18. So we will choose different color and drop the weight. So 15 is over here and 18 would be 4, 12, 4, 8, 12, 16, 18 would be over here. So, right, okay. Then we have 46. Actually, wait. Four, 8, 12, 16, 18. Okay. Next up was 25 and 46. So 25 and 46. So 44, halfway between 44 and 46. 88, that is 30. So 84, 88. Then we go 140 at 40. So halfway over here. Then we get 176. So let's see. 4, okay. 4. So, right. Wait, sorry. What was the number? 50? No. Yeah, 50, okay. So 164, 168, 172, 176. Yeah, 4.4. Okay. Then we have 200 at 70. Right. Okay. So now we just need to clean this up. Oh, sorry. We just need to clean this up a little bit, enough to be able to sketch this. So let's choose right. So let's hope we are able to make this as properly as we can. Oh, no. Let's try this. So, okay, let's erase this part and try again. And this, sort of like this. Okay, we can try the bottom patch again. It's not perfect, but okay, that's fine. I use the graph to estimate the median and interquartile range of the data. So median would be at 100. So 100 is right over here. I think we can increase the width now. So halfway. So wherever it's meeting, let's go down. Oh, sorry, no. Right. Actually, our graph is actually meeting right over here. Okay. And this is the median, right? So now we need so at 150, right? Because it's 100 and 200, so we need it at 150. So this is 140. So 150 would be right over here. So let's try again. Okay. And 50, this is 60, 50 right over here. Okay, let's make that. Okay, and okay, so we need the values now. So this seems to be 32 roughly. This is 42.5, and this is, let's try again, 25 basically. Okay, right. So right, okay. So Q2 is around 32, Q1 is 25, Q3 is 42.5. So that means the interquartile range, which is the difference between the upper quartile and the lower quartile, 42.5 minus 25, that is 17.5. This is our median, and therefore this is our interquartile range. Right, okay. Calculate an estimate for the mean value of the times taken by the 200 people to walk to school. Now for the mean, remember this is a grouped frequency table, so we need the mean for the class intervals, right? And then we need to multiply with cumulative frequency and then divide by that also. Okay, so we actually need a different table for this. So we will need to make, oh, we have enough space, okay. So we have first from 0 to t to 15, then we have 15 to 25, 30, 40, 50, 70. 30, 40, 50, and 70, right? 15, 25, 30, 40, 70. Okay, so that's what we have. So this would be from 30, this would be from 40, now 50. So the next item on the agenda, these are class boundaries. We need the midpoints. So 7.5, this would be just 20, 27.5, 35, 45, 60, and now we need the frequency. So you see we need to extrapolate these from cumulative frequency graph. So the first is 0 to 15 is 18. Then the next one was 46, so 46 minus 18. 28. Then the next one after that is 88. So 88 minus 46 is 42. Then 140 minus 88, 52. Then 176 minus 140, that's just 30. And the other one is just 24. Right, so we can see what we get. If it adds up to 200, that means we were right. 42 plus 52 plus 30 plus 20. Oh, sorry. 184. Wait. 18, 28, 42, 52, 30, 24. Okay, that means we missed something. Was it 18? 46 minus 18 is 28. 88 minus 46. Oh, this was 42. No, we wrote that correct. Then we have 140 minus 88, 52. 176 minus 140, 36. Oh, 36. This was 36. Sorry. Oh, right. Now we get 200. Okay. Right. So now for the mean, we multiply the midpoints. Let's call them x bars, and the sum of f. So 7.5 times by 18 plus 20 times by 28 plus 27.5 times by 42 times by 35 times by 52 plus 45 times by 36 plus 60 times by 24, and then divided by 200. 7.5 times by 18 plus 20 times by 28 plus 27.5 times by 42 plus 35 times by 52 plus 45 times by 36 plus 60 times by 24 divided by 200. So 33.65. So 33.7 you can say. Alright, so that is for this question. Let's move on to the next one. Question number 4. Rahul has 2 bags, X and Y. Bag X contains 4 marbles, 4 red marbles and 2 blue marbles. Bag Y contains 3 red marbles and 4 blue marbles. Rahul also has a coin which is biased so that the probability of obtaining a head is 1/4. Rahul throws a coin. If he obtains a head, he chooses a random marble from bag X. He notes the color, replaces the marble in bag X. He then chooses a random second marble from bag X. If he obtains a tail, he chooses a random marble from bag Y. He notes the color and discards the marble. That means he doesn't replace it. He then chooses a random second marble from bag Y. Right, okay. Find the probability that 2 marbles that Rahul chooses are the same color. Okay. So first we would need to draw what we would say, probability tree diagram. So we have sufficient space for this. So if he chooses a head, is 1/4. This would be 3/4. Right? If he chooses a head, he chooses a random marble from bag X. Okay, so from bag X, the four red marbles and two blue marbles. So red 4/6, blue is 2/6. Then he replaces it. He then chooses a random second marble from bag X. So you see, he is replacing it. So the second time would also be identical because he is replacing it. Okay, so 4/6, 2/6, 4/6, 2/6. Right. If he obtains the tail, he chooses a random marble from bag Y. Now things will be different. So bag Y, 3 red marbles, 4 blue marbles. So red is 3/7, blue 4/7. Okay. Right. He notes the color and discards the marble. He then chooses a random second marble from bag Y. Okay. Then again this continues. So the second time red would be 2/6, and this would remain the same, 4/6. If he chooses black first, then this would be 3/6, and blue would be 3/6. Right, okay. We need the same color, right? So this is our R, this is our B, this is BR, this is BB, RR, RB, BR, and VB. So how many times do we have the same color? RR, BB, RR, BB. Now we need the probabilities for these. So let's choose a different color for this. Black is fine. So 1/4 times by the square of 4/6. Okay. Then same from head. Actually, I should have written head, 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 head. This is now tail, 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 tail. Right. Okay. This one was this same color now as this. This is now 1/4 times by 2/6, 2/6. So this is 2/6 whole square. Then you have TRR, which is 3/4 times by 3/7 times by 2/6. Then this one you have 3/4 times by 4/7 times by 3/6. So probability that chooses same color. You could also say RR or BB. This would be, you can simply write it now, 1/4, 16/36 plus 1/4 times by 4/36 plus 3/4 times by 3 times by 2, 6/42 plus 3/4 times by 12/42. Okay. So 4 times by 36 is 144, and 4 times by 42 is 168. Okay, so 16 plus 4 is 20, plus 18 plus 36, 54. Right, okay, so 20 divided by 144 plus 54 divided by 168. So that is 29 over 63. Alright, let's move on to B part. Find the probability that two marbles that Rahul chooses are both from bag Y, given that both marbles are blue. Given that both marbles are blue. So you are getting BB from bag Y, given that they are both marbles blue. So basically from the BB choice, we have to select. So these are the two BB choice. We have to select this one out of both of them. So 3 by 4 times by, I need that again, right, okay, given that, right, okay, so 4 over 7, 3 over 6 divided by, same thing, plus the first one, 1/4, 2 by 6 whole square. Sorry, 2 by 6, yes. Right, okay. So we have 3 divided by 4 plus 4 divided by 7. Oh, sorry, no. 3 times by 4 times by 3 divided by 4 divided by 7 divided by 6. 3 times by 4 times by 3 divided by 4 divided by 7 divided by 6 plus 4 divided by 4 times by 36 divided by 4 divided by 36. 54 over 61. Right, so that is question number 5. Let's move on to question number 6. The weights of the green apples sold by a shop are normally distributed with mean 90 grams and standard deviation 8 grams. Okay, find the probability that the randomly chosen apple weighs between 83 grams and 95 grams. Okay, so first off, we need to standardize this. So you have a weight normally distributed 90 and variance is 8 squared. So probability that weight is between 83 and 95 first has to be standardized. So this would be 83 minus 90 divided by 8. 95 minus 90 divided by 8. So minus 7 over 8 less than z less than 5 over 8. So we need the values. 7 divided by 8, 8. 0.875 and 5 over 8 is 0.625. Right. Now, even before we go into the table, we know how to look for it. So, this is your 0 mean. Minus 0.875 is over here, and the 0.625 is right over here. So we need the area in between this, right? So we can't directly do that because we don't have this, right? So what we actually need is simple area minus area, right? So we can split it first. So z less than 0.625 minus probability of z less than minus 0.875. But we can't do that either because we don't have access to this area, because we can't figure out this number. So remember, when we have the negative number, how we handle that? The same area over here is identical over here. Okay, so this would be just simply 1 minus the area of the positive value. So probability of z less than 0.625 minus 1 minus probability of z less than 0.875. So as it suggests, you will be adding 0.625 probability with 0.875 with minus 1. You can also write it in terms of phi, so basically like phi of 0.625 plus phi of 875 minus 1. Either way, we need to now go to the table and figure out the probabilities. So let's highlight the values that we need. So 0.62, that means this, and 5 means we need to add 16 on it. So 0.7324 plus the last two digits, 0.0016, so 0.734. Okay, so the first number is 7340. Okay, next one was 875, so 0.87 and 5. So same thing, 0.8078 plus 0.0014, so we get 0.8092. Alright, so first I'm gonna write these values in the calculator so I don't forget it. 0.8092 minus 1. So that's the value that we're looking for. So we get this one was 7340 plus 0.8092 minus 1. This is equal to 0.5432. You can round it up to 0.543. Right, okay. The shop also sells red apples. 60% of the red apples sold by the drop weigh more than 80 grams. Okay. 160 red apples are chosen at random from the shop. Use a suitable approximation to find the probability that fewer than 1/5 of the chosen red apples weigh more than 80 grams. Now, the first thing, the first two lines point to binomial distribution. So you see 60% of the red apples sold by the shop, right? So that means the probability of success is 0.6, the probability of failure is 0.4, and the n is basically 160, right? So we need to approximate it to binomial. So first we have binomial distribution NP 160 0.6. We then approximate it to normal distribution. So normal, remember, mean is NP and variance is NPQ. So NP is 160 times by 0.6, that is 96, and NPQ, that is your variance, so that is 38.4. So remember, it's not just the NP and the NPQ that we need to remember. We also need to do the continuity correction, because we have just went from discrete variable to continuous variable, right? So we need to convert 105. So because you have weight 105, it needs to be converted. First it was binomial. Now we need it in. Now we're approximating it as a continuous variable. So this would become, see, always remember it's less than 105. So the upper bound we will select for the normal one. So 105.5. So now we need to standardize this. So 105.5. Yeah, okay. 5.5. Oh no, sorry, no. Less than 105, no? Sorry, this would be 104.5, sorry. You're right, sorry. 104.5 and 4.5 minus 96 divided by the square root of 38.4. So 104.5. If they had written less than equal to 105, then we would select as 5.5. 96 divided by square root of 38.4. So we get 1.37168. So basically 1. No. Sorry, what am I doing? So probability of z less than 1.37. We need it to 3 decimal places, so like this. We go back to the table. So we need 1.37 and 2 to this. So 0.9150 basically. Right. So we go back to the table. So 0.9150. And that's it for this question. Let's move on to the next one. Question number 6. The heights of the female students at Brevin College are normally distributed. Okay. 90% of the female students have heights less than 182.7. 40% of the students have heights less than 162.5. Okay. So since they're normally distributed, we don't know the mean and we don't know the standard deviation. But they're giving us a clue to these two. So they're giving us two conditions. So they're saying that it's normally distributed. Let's call it H, normally distributed. We don't know the mean. We don't know the standard deviation either. However, when we standardize it, let's call it Z1. From condition 1, basically you can say 182. So Z1 is 182.7 minus mu over sigma, and Z2 is 162.5 minus mu over sigma. So they're saying the probability of heights less than, so less than, let's call it Z1, is 90%. And Z less than Z2 is 0.4. Okay, so now that's what we need to figure out. Alright, so we go into the table and figure out which Z values correspond to 0.9 and 0.4. So, first off, we can find it over here, 0.90 already. Oh, sorry, no. First value is easy to spot, 0.90, 1.282. I'm going to write it over here before I forget. 1.82, and not plus with next up is Z less than 0.4. So we are never going to find that. Why? Because the standard normal table starts at 0.5. So you see over here it starts at 0.5. So what we can do over here, we use the symmetry property. So if we're looking for the area less than 0.4, let's say some z2 value that this satisfies that, the same z2 value would satisfy this area also. That means this means that this would be the positive z2. So probability z less than positive z2 is 0.6. So if we can figure out where 0.6 is, we can figure out the positive value of that, but still we would need it. Yeah, right, okay. So 0.6, we need to figure out where 0.6 is. So between these two values, so 0.25, and we need to see which we'll get that. So 0.6 minus 0.5987, so we need to add 0.13 to it. So I think this would be the closest thing that we can go to, right? So like this. Oh no, sorry, no. Between 0.253. Okay, wait. 0.25. Sorry, what am I doing? 253. It's going to be (0.112). So basically you have a difference of 0.001. So okay, wait, let's make this over here. 87 plus 0.0012, this is this value 0.5999, and this thing 254, it's 16 after, so 0.6003. We need it at 0.6, so we can do a little bit of linear interpolation to figure out this also. So z minus 0.253 over 0.6 minus 0, it's going to be a very small difference, but you can still do the linear interpolation. So 0.254 minus 0.253 divided by 0.6003 minus 0.5999. So, okay, you have 0.254 minus 0.253 divided by 0.6003 minus 0.5999 times by 0.6 minus 0.5999 plus 0.253. Right, so 0.25325. Okay, so we can use that. So I'll just gently copy this so we have a record of doing this. So we go back to the paper. Right, so we paste this. Right, so okay, never mind. So we get the value for what was the first? Oh, I forgot the first one. 1.282. It was z1 was this, and the z2 we got was 0.25325. Right, and this was negative, remember, so this would be negative. So this is z2. Okay, now we need the mu and the sigma, mean and standard deviation. Right, okay, so we have two values for this. Okay, For Z1 we have 1.282 sigma plus mu equals to 182.7. The other one is minus 0.25325 sigma plus mu equals to 162.5. Right, okay. Now we subtract these two equations together. So this becomes plus, this becomes minus, this becomes minus. So we add these 1.282 plus 0.25325. This is 1.53525 sigma, and this would be 182.7 minus 162.5, 20.2. Now we need this again, so 20.2 divided by 1.53525. This is 13.157. For mu, we can do 182.7 minus 1.282 times by 13.157. So we save this. 182.7 minus 1.282 times by answer. So we will get 165.832. So therefore mean is 165.8. So why we're using one decimal place? Because as you can see, one decimal place, and one decimal place. Sigma, this would be also 13.1 or 13.2. Either way, it's fine. 10 female students are chosen at random from those at Brevin College. Find the probability that fewer than 8 of these students have heights more than from those at Brevin College. Same thing? Right, okay. We now have the mean and the standard deviation. Fewer than 8 of these 10 students have heights more than 162.5. Oh, okay. So basically we have the mean, we have the standard deviation, and we know that we also know the probability, right? So probability of the female students of having height less than 162.5 is 0.4, right? So this is now binomial. So n is now 10, p is 0.4, q is 0.6. So we are looking for probability x less than 8. So heights more than, sorry, no, wait. Oh, wait, sorry, no, wait. The 40% of the female students have heights less than that, so that means 60% of them will have more than that. Okay. Sorry, this was a tricky thing. Now we need the binomial. So NCX P raised to power X Q n minus X. So fewer than 8, so we have 10 C X 0.6 raised to power X, and oh sorry, this is going to be sigma also, right? So from X is equal to, okay, from X is equal to 1, no, 0. From X is equal to 0 to X is equal to 7. Because we need, we are starting from 10C0, where all of them, right? So all of them have less than 162.5. that all of them are failure basically. So sigma x is equal to 0, 7, and right, so q is 0.4. That is just simply 10 minus x. Okay, so we plug this into this. So 7, 0, 10 c x times by 0.6 raised to power x times by 0.4 raised to power 10 minus x. So we get the value 0.8327. So 0.833 to 3 significant figures. Right, and that's it for this question. Let's move on to the next one. Question number 7. How many different arrangements are there of the 9 letters in the word intellect in which the 2 T's are together? Now, different arrangements, right? Different arrangements. That means we need to take care of 2 E's, 2 T's, 2 L, right? 9 letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2 L's are together. That means we are going to consider them as one group, and we don't need to take care of the arrangements inside the group. But we still have 2 E's and 2 L's. So we have how many units? 1, 2, 3, 4, 5, 6, 7, 8 factorial divided by 2 factorial, 2 factorial. Remember, we don't need the 2 L's, we just need 2 for 2 E's. So 8 factorial divided by 2 factorial divided by 2 factorial. So this is 10,080. Alright. How many different arrangements are there of the 9 letters in the word intellect in which there's a T at each end and 2 E's are not next to each other? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this T or this T, they are going to be identical to each other. So it doesn't matter which of these T are at the end, because they're identical. And we need different arrangements. 2 E's are not next to each other, but we still have 2 L's, remember? So you have 2 L's maybe like this. So from the 9 letters, T's are already placed, L's are duplicate, and 2 E's cannot be next to each other. So you can first find out how many options there can be minus where the 2 E's are together. So if we do that way, actually there's more than one way of handling it. So if we place E, so for example you have E over here, then it can't be here, right? Right? Or it can come over here. Alternate places. Okay, so a better way would have been to just write whatever it was left. We have I, we have N, T is gone, we have L, we have L, we have C. Right, so 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right. So we can have E over here, we can have E over here, E over here, E over here, E over here, and E over here. So these 5 will have different arrangements. 2 L's duplicate times by 1, 2, 3, 4, 5, 6, 6 P 2 for two e's together. And remember, these are two identical, so we will divide them by 2 factorial. Actually, we could have done 6c2 also, because these two e's are also identical. So this would yield the same answer. Another way we could do this is, I think, the first method that I said. We choose with no restrictions. So t at the end, 1, 2, 3, 4, 5, 6, 7. We have L's, we have E. So no restriction means 1, 2, 3, 4, 5, 6, 7. 7 factorial divided by 2 factorial when they're together, minus when their e's are together. So when e's are together, we will consider them as one unit. So 1, 2, 3, 4, 5, 6 divided by 2 factorial for the two L's. So let's see what answers we get from each of them and whether they match or not. So the first one, 5 factorial times by 6p, times by 6p2 divided by 2 divided by 2, 900. So if we replace one of them by 6c2 instead, you see same 900. Now we test the second one, 7 factorial divided by 2 factorial divided by 2 factorial minus 6 factorial divided by 2 factorial, which is just 2. So as you can see, we're getting 900. Okay. 4 letters are selected at random from the 9 letters in the word intellect. Find the percentage of possible selections which contain at least one E and at exactly one T. So let's make a table for that. So at least one E, so that means for E's and for T, and exactly one T. And the others also, obviously, like non-T. So you will have I, N, L, L, C, 5, right? So at least one E means that you have either one E or two E's, and T's are exactly 1. So we are selecting 4, right? So that means 2 from these, and in this case 1 from these. So let's make that. So there are 2 E's, 2C1 times by 2C1 for T and 5C2. Then you have 2C2, 2C1, 5C1. Right, okay, now we just need to add them. 2C1 times by 2C1 times by 5C2, this is 40. And 2C2, 5C1, 10. Okay. These will be the selections with this, but total selections would be, total random selections would be 94, right? No restrictions. So therefore the percentage would be 40 plus 10, 50 divided by 9C4 times by 100%. So 50 divided by 9C4 times by 100, so we get 39.68%. You can write it as 40. You can write it as 39.7, sorry. 39.7%. Right, and that's the end of this paper. Hopefully you enjoyed and understood the reasons that we were giving. If you have any confusions, doubts, or problems, feel free to reach out in the comments. I would love to help you out with your doubts and questions. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. Also, feel free to share this with your friends and family if you like this. If your friends or classmates are struggling in statistics, do share them this video. Furthermore, if you would like some one-on-one coaching, we are also open for that. The link, you can see that in the description, the link tree. You can navigate and apply for that. You can also text us on WhatsApp. You can email us. All links are available on Linktree. So do reach us out if you would prefer a one-on-one coaching. And until the next video, take care of yourself. Bye-bye.